Weather is one of the few sciences where you see it all happening around you every day, and it has an impact on your day-to-day decisions.
College Station and Brazos County is what's called a radar gap region.
As you get farther away from a radar, the beam from the radar is higher above the ground.
We are far from big metro areas of Dallas and Houston, which have their own radars. The new radar fills the radar gap and allows us to respond more quickly to emergencies.
Things like tornadoes and precipitation are happening much closer to the ground, so to get accurate measurements of those, you want to be relatively close to a radar. So these climate vision radars are gap filling in the sense that they're placed in between the next-rad radars, so they get better low-level coverage in areas where the beam from the next-rad radars is too high.
Climate Vision has a bunch of radars, and we're actually going to get a chance to not only get the data from our radar, but all the Climate Vision radars.
I think the sky is the limit, really, in terms of what we can do with this. A lot of professors here use radar. This is another tool that we can add to that for research projects, not just for Texas, but for the whole country.
The meteorology department goes back to the 50s, and originally it was called the Department of Oceanography and Meteorology. In the 60s, it split into meteorology and oceanography. And this department was mostly focused on teaching for many years, till the 80s, from the 60s to the 80s. And then in the late 80s and 90s, it started expanding out into research in meteorology. And the research got much broader than meteorology, and in the late 90s, it got renamed into the Department of Atmospheric Sciences.
We're one of the largest undergraduate meteorology programs, and students are really learning the nuts and bolts of the weather and climate, how to forecast the weather, but also how to improve forecasting. But it's a little bit more than just weather and weather forecasting. A lot of our students are interested in climate change related problems. We also have a strong component of our program and faculty that work in air quality and atmospheric chemistry.
We've become much broader. So right now, we are very active in all the major areas of atmospheric science.
What makes A&M so special is the amount of opportunity that we have for our undergrads here. We are a smallerish program, getting bigger, but because we're kind of in that smaller range, we have so much opportunity for undergrads. I got to start doing undergrad research as early as a sophomore, and then once I got into junior year, I was already employed by the Office of the State Climatologist and the Southern Regional Climate Center. And that's just really bolstered all the opportunities, and it's hopefully gonna lead me to a master's degree.
Our students really learn strong analytical skills, data analysis skills that really serve them in their careers going forward.
The National Oceanic and Atmospheric Administration Southern Regional Climate Center is also located in this department. So we provide a variety of services to the state of Texas. One of the unique features of the Department of Atmospheric Science is the radar on top of the O&M building, which is sort of a local landmark. And this radar has been on the building ever since the building was built over 50 years ago. It's an S-band radar, which is pretty large, about 25 feet in diameter. And it's operated by us, by the department, by the students and the faculty. And it's played an important role in our instruction. It was affectionately called the Aggie Doppler radar, or ADRAD. But it's pretty old, as I said, it's over 50 years old just on this building. And its mechanical parts have been rusting, and it's hard to turn the radar around, even though its electronics actually is functional, although it's very old. And it was also getting hard to find people to fix it. A 50-year-old radar, you can't really find engineers who know how it works to fix it.
In the US, we have a network of radars called the NextRad Radar Network that's operated by the National Weather Service. Those radars are spread probably about 200 or 300 miles apart from each other, depending on where you are in the country.
Because of the curvature of the Earth, a radar beam goes straight, and so a radar located in Dallas or Houston, by the time the radar beam reaches it, it's up quite high and it won't see the low-level atmospheric features. Having a local radar in College Station will allow us to detect features below 4,600 feet. Less than a year ago, a company called Climate Vision approached us via the Texas A&M Emergency Services, saying they would like to install a new radar on top of the O&M building. They would do it for free in return for us providing the space and the power to operate the radar.
We have a partnership with ClimateVision that their scientists can help our students learn how the radar works, how the new technology is different than older radars, and they'll have the ability to physically visit the hardware, see how radars actually function, and do projects with the radar data that will not just help the students learn, but will also feed back and help ClimateVision hopefully improve the quality of their data by allowing us to students and faculty to compare their data with other instruments that we have.
It can detect smaller particles because its wavelength is smaller.
We're going to get much finer detail on the storms that do occur near College Station, and that's going to really help the students learn more about the weather itself too, not just how radars work.
I think that's going to bring a whole new bunch of opportunities of what we're able to do in that class, what I'm able to learn. It's going to be so different.
Part of the deal with ClimateVision is that they'll give us real-time data from the radar for our students to use in our radar meteorology course. And they'll also share it with the Texas A&M Emergency Services and I believe also with the local city authorities. The reason ClimateVision wanted to do this is because they're a business and they sell the radar information to radio stations and other services to improve forecasts. Initially, a big crane was supposed to be built near the building to replace the radar. For some reason, this crane didn't work out and ClimateVision switched to using a helicopter. After the radar was installed in June, we've still been fine-tuning the actual signal and it's almost ready to be operational. And so we're really looking forward as a department to having this unique facility, and the emergency managers also looking forward to having this extra information that'll help them respond to local emergencies. And this came out of the blue and it came gift wrapped in some sense at no cost to us. So I was very happy with that.
This radar is state-of-the-art technology, especially compared to the old radar that we had.
With this increasing need for very accurate local weather information, and radars like these are going to be the ones that are going to provide it. That's input to models that will predict the local weather.
Having a radar that's running 24/7, we're not going to miss anything. So the students will have access to see all of the data for interesting weather around here, and we'll be able to use more data in their class projects. And again, they'll be able to see how more cutting-edge technology is used in radar meteorology. So I see all those things as benefits of this new radar.